Hello, hi everyone. Hello, hi everyone. Welcome to the student brand. This is your Shiva sir. Today we are discussing about light reflection and refraction. Light reflection and refraction. Okay, so let's start the topic. So light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay, so I'm taking here light reflection and diffraction. Light reflection and refraction. Reflection and refraction. Refraction. Okay, so when light incident on the surface, it reflect back. The bouncing back of the light from the reflecting surface is called reflection of light. So I am taking this a plane surface. I'm considering a plane surface. One side is coated silver coating, another side is reflecting surface. One side is silver coating, another side is reflecting surface. Okay, so these are incident light rays. Incident light rays are parallel to each other. Incident light rays are parallel to each other. Then reflected light rays are also parallel to each other. That is called regular reflection. Regular reflection. Incident light rays are parallel, then reflected light rays are also parallel to each other. That is called regular reflection. Okay, so first of all we have to discuss about reflection of light ray. So what exactly is the reflection of light, so how it is. So first we will discuss about reflection of light. Okay, so reflection of light is nothing but reflection of light, the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface. When light is incident on it, after reflection, the light ray will reflect back. Okay. Okay, so light rays are coming. Understood or not? So light rays are coming from infinity. So we don't know the point. So somewhere light rays are coming. So that's why we are considering. Okay. So always light moves in a straight line path in a homogeneous medium. So if light ray is coming from infinity, so it is coming from homogeneous medium. So it is traveling in a homogeneous medium. That is air. So that's why those lines are parallel lines. Those lines are straight lines like that. Okay, so if the light incident on the surface, so the light which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called a reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Understood or not? So here I am considering this. Here I am considering this one. Okay. So incident ray, reflected ray, and the normal. So this is the normal. Understood? So incident ray and reflected ray. This is a reflected ray. Incident ray and reflected ray. And coming to this one is the normal. Normal. The angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle of incidence. Angle between reflected ray and normal line is called angle between reflected ray and normal line is called angle of reflection. Angle of reflection. So angle between incident ray and normal line. So angle of incidence, angle between reflected ray and normal line, angle between reflected ray and normal line is called angle of reflection. Understood or not? So incident ray, reflected ray, normal line. Angle between incident ray, angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection. Okay. So, and you can observe, so this is the undeviated line. Undeviated line. Undeviated line. Understood or not? Undeviated line. Okay, undeviated line is nothing but, so initial direction of the incident ray. Initial direction of the incident ray. So the angle between reflected ray and angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Okay. So the reflecting back of light from the reflecting surface is called reflection of light. Or the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Coming to laws of reflection. Laws of reflection. Laws of reflection. Laws of reflection. Point number 1. Incident ray, reflected ray. Incident ray, reflected ray. Incident ray, reflected ray. Understood? Incident ray, reflected ray, normal line. So incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. And so this is about loss of reflection. This is about loss of reflection. And coming to the next one. So this the angle you are taking, that is 180 degrees. 180 degrees. So that is angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Understood? So angle of incidence is equal to angle of reflection. So angle of incidence plus angle of deviation equal to minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. Understood or not? Angle of deviation equal to 180 minus 2 angle of incidence. Angle of incidence. Angle of incidence. So you can angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear. Angle of deviation and angle of deviation. So now we can see, coming to regular reflection and irregular reflection. So we'll discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. So now you can see here, so I am taking this is a regular reflection, regular reflection, regular reflection. So plane mirror, incident light rays are parallel, incident light rays are parallel, then reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. So that type of reflection is called regular reflection. Okay, so you can see here this about incident light rays are parallel. After reflection, reflector light rays are also parallel to each other. This is called regular reflection. Coming to irregular reflection, incident light rays are parallel, incident light rays are parallel, but reflector light rays are not parallel to each other. So incident light rays are parallel, then reflector light rays are not parallel to each other. So I am taking here, so you can observe incident light rays. These are incident light rays 1, 2 and 3 and 4. These are incident light rays. So, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. Okay, so that type of reflection is called irregular reflection. Irregular reflection. So you can observe like this. So regular reflection, so incident light rays are parallel, then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. And coming to irregular reflection, irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So incident light rays are parallel, but reflector light rays are not parallel to each other. Understood or not? So this type of reflection is called irregular reflection. Understood or not? Yes. Incident light rays are parallel, then reflector light rays are also parallel to each other. That is called regular reflection. Incident light rays are parallel, but reflector light rays are not parallel to each other. That is called irregular reflection. Irregular reflection. Understood? Regular reflection and irregular reflection. Regular reflection and irregular reflection. So regular reflection takes place on plane mirror. Regular reflection takes place on plane mirror. So you can say a still lake of water surface. Okay, so on that it will take, and regular plane mirror also regular reflection takes place. Coming to irregular reflection, so irregular reflection takes place on rough surface. Best example, wall, you can say wall. So there irregular reflection takes place. Understood? Irregular. Now we will discuss about object and image. Okay, let's discuss about object and image. Object and image. So this is the real object and virtual image. Real object and virtual image. So from the light rays, okay, so now you can observe, you can see here. So object I am taking, next one. So here you can take, these light rays are coming from, and these light rays are coming from here. After reflection, those light rays are moving like this. So this is the real image. and I am extending these light rays. Extended light rays are meeting at one point. That is a virtual object. Virtual object. Understood? So here you can observe. Here you can observe. From this point, light rays are coming. That is a real object. After reflection, so we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. And coming to here, so these are the reflector light rays. After reflection, those light rays are meeting at one point. So that is a real image. If you are extending the incident light rays, extended incident light rays are meeting at one point, that is a virtual object. That is a virtual object. I hope it is very clear, right? So from this one we can understand, object is real, object and image. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Okay, so this is about. So what is this one? This is about object and image. Object and image. Next one. So we'll discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Let's start. Nature of the image formed by the plane mirror. So you can see here. This is A and B. This is A and B. Okay. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays are required to form the image of the object? Minimum 2 light rays. Yes or no? So minimum 2 light rays are required to form the image of the object. Okay. So now you can see here. Now you can observe. So minimum how many light rays? Minimum 2 light rays are required to form the image of the object. Okay. So if the light ray is passing along the normal line, so if the light ray is passing like this along the normal line, it reflects back in the same direction. If the light ray is passing along the normal line, it reflects back in the same direction. Okay. So you can observe here. So that's why I am taking here also. When light is incidenting on the surface, okay, so that is, so here you can observe, this is the incident ray, and if the light ray is inciding along the normal line, it reflects back. So how many light rays? I said 2 light rays, right? So one more light ray I am taking like this. After reflection, it is moving like this. Another light ray is also moving like this. And here you can observe, if you are extending those light rays, extended light rays are meeting at one point. Okay, so if you observe here, these extended light rays are meeting at one point. So here, so I am extending these light rays and extending these light rays. These also extending and these also extending. So their image will form. What type of image? Virtual and erect and same size. Virtual, erect and same size of image will form. Okay, so here you can observe point number 1. Point number 1. Object is real, image is virtual. Object is virtual, image is real. So you have to understand one thing. So if the object is real, image is virtual. If the object is virtual, image will be real, right? And also Object distance is equal to image distance. In the plane mirror, the distance between object to mirror, so is the object distance, and the distance between mirror to image is called image distance. So object distance is equal to image distance. Object distance is equal to image distance. And also here you have to understand one thing. Height of the object is equal to height of the image. Height of the object is equal to height of the image. So third one, height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Okay, object is real, image is virtual, object is virtual, image is real. Point number 1. Object distance is equal to image distance. Point number 2. Height of the object is equal to height of the image. Point number 3. And also the magnification of the plane mirror is +1. That means height of the image by height of the object is equal to +1. So what do you mean by height of the image by height of the object is +1? Because so what type of image will form? Virtual, erect and same size of the image will form in the plane mirror. Virtual, erect and same size. So magnification equal to +1. Okay, and here you can observe fifth one. It also shows lateral inversion. It also shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Understood? So I hope it is very clear. So check once here. Next one. So till now we discussed about plane mirror. Now we will discuss about spherical mirrors. Let's start. The mirror which in the form of curved shape. So that is called spherical mirror. So concave mirror is there. So the whenever light rays incident on it, so after reflection the light rays will meet at one point. That is called so concave mirror. And also it is known as converging nature. Coming to the convex mirror is in diverging nature. Whenever light rays are incident on it, after reflection those light rays will move away from it. Okay, so concave mirror. And coming to the convex mirror, this is a concave mirror and a convex mirror. Okay, convex mirror. So concave mirror and convex mirror. So coming to the terms related to spherical mirror. Terms related to spherical mirror. Okay, so this is a spherical mirror. So the terms, if you take the center of the imaginary sphere in which mirror is a part, this is the center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. First one is center of curvature, second one is pole, third one is the line joining of center of curvature and pole is called principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. Okay, the distance between center of curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point. So here you can observe. So I am explaining this point. That is nothing but, so after reflection, when light rays are coming from infinity, after reflection, those reflected light rays are meeting at one point on the principal axis. Okay, so that point is considered as focus. So that point we can say focus. That point is named as focus. Okay, So that is the focus point. And coming to the sixth one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And also we can take one more point, that is aperture. Aperture is nothing but width of the reflecting surface or diameter of the reflecting surface. Point number one, the center of the imaginary sphere, the center of the imaginary sphere in which mirror is apart, that is called center of curvature, and the midpoint of the mirror is called pole. And so the line joining of center of curvature and pole is called a principal axis. After that, the distance between center of curvature and radius of curvature. So the distance between center of curvature to pole. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole, center of curvature to pole is called radius of curvature. The line joining of center of curvature and pole, the line joining of center of curvature and pole is called principal axis. Principal axis. And after that, so we'll discuss one more point, that is focus. Simply, actually it is a principal focus. Actually, we have to call it is a principal focus. But so simply in the simple form, we can say focus. So what is the meaning of focus? After reflection, so light rays are coming from infinity, those light rays will become parallel to the principal axis. After reflection, those reflected light rays will meet at one point on the principal axis. That point is called focus. That point is called focus. The distance between focus to pole is called, the distance between focus to pole is called focal length. And width of the reflecting surface, okay, so our diameter of the reflecting surface, are so where reflection of light takes place, that surface is called aperture. Okay, so aperture. So here I am talking about aperture. This is the aperture. So center of curvature, pole, principal axis, radius of curvature, focus, focal length, aperture. So these are the terms related to spherical mirrors. Terms related to spherical mirror. So now we will discuss about ray rules. So ray rules of concave mirror and convex mirror. So here there are four ray rules are there. So if you want to go for war, what you need? You need weapons. Okay. So without weapons, you can't able to do war. So here, if you want to draw the image formations, you need a ray rules. Okay, you need ray rules to draw the image formations. So here I will discuss about four ray rules. Okay, so I will discuss about four ray rules. Those are very very important. Ray rules. Without that, we can't able to draw the image formations. Compulsory you have to learn these four ray rules. Okay, so four ray rules, that is for concave mirror and convex mirror also. So ray rules are common for concave mirror and convex mirror also, but image formations are different. Image formations means according to the object position, so image position will change. Image position will vary. Image position is varying according to the object position. So that is called a formation of image by concave mirror and convex mirror. So simply we can say spherical mirror. Formation of images by spherical mirror. Okay. So now we will discuss. So the next topic is that is ray rules. I am taking this a concave mirror. So just now I mentioned here, this is the pole, focus, center curvature. Pole, focus and center curvature. So light ray is coming from infinity. After reflection, that light ray will pass through focus. So when light ray is coming, you need to understand one thing, you have to observe one thing. When light ray is coming from infinity, so that will become parallel to the principal axis. After reflection, a light ray is coming from infinity, so it will be parallel to the principal axis. After reflection, it should passes through focus. So the same second one is reverse of the first one. If the light ray is passing through focus, after reflection moves towards infinity, become parallel to the principal axis. That is second one. Coming to the third one, if the light ray is passing through center of curvature, after reflection it retraces its original path. And coming to the fourth one, light rays is incidenting at the pole, it reflect back. Okay, when light ray is incident at the pole, after reflection, that will reflect back into the same medium. Here you can take, that is the first one. And coming to the second one, so I'm taking here, this is the pole, focus and center of curvature. Light ray is passing like this. After reflection, it moves towards infinity, become parallel to the principal axis. And coming to the third one, light ray is passing. So this is the pole, focus, center of curvature. Light ray is passing through center of curvature. After reflection, it retraces its original path. It moves in the same direction. It retraces its original path. It moves in the same direction. It reflects back into the same medium. So anything we can say. Okay. When light ray is passing through the center of curvature, after reflection, the reflected ray retraces its original path or moves in the same direction or reflect back into the same path. Okay, so like this we can say. And coming to the fourth one. So I'm saying here, this is the pole and focus and center of curvature. When light ray incident at the pole, it reflect back. So point number one, so observe carefully. If the light ray is coming from infinity, the light ray is coming from infinity, after reflection it passes through focus. Light ray is passing through focus, after reflection moves towards infinity. And coming to the next one, okay, light ray is passing through center of curvature, it retraces its original path. And next one, light ray is incident at the pole, it reflect back. Okay, so these are the light rays. Okay, so ray rules of concave mirror. Coming to the convex mirror, na ni na ni na na ni na na, pole focus center of curvature, light rays passing after reflection, it passes through focus, turn, pole focus, center of curvature, light rays passing through focus, after reflection, it moves towards infinity. Coming to the next one, light rays, pole focus, center of curvature, light rays incidenting so here you can observe light rays coming from infinite, after reflection passes through focus. Light rays passing through focus, after reflection moves towards infinity. Light rays passing through center of curvature, it retraces its original path. Light rays incident the pole, it reflect back. Okay, so these are the ray rules of concave mirror and convex mirror. So this is the concave mirror and this one is a convex mirror. I hope it is very clear. So now we will discuss about image formations. Okay, so here you can observe concave mirror image formation. Let's start concave mirror image formations. So I'm taking the concave mirror. Here you can observe pole. Every time you are drawing the concave mirror, you must represent these points. You have to represent this point. Compulsory you have to place. You have to nomenclature. Okay, so you have to mention, you have to represent, you have to place the points. Those are pole, focus, center of curvature. Pole, focus, center of curvature. So after mentioning, then you can take the object. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Object is at infinity. Image is formed at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Highly diminished. So that is the point number 1. Coming to the point number 2. Light rays play. Object is placed. Object is placed beyond center curvature. Here you need to understand one thing. If the object is placed beyond center of curvature, so here I am taking this the pole, focus, center of curvature. Object is placed beyond center of curvature. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Okay, so one light ray I am taking like this. So one light I am taking like this. After reflection, that will passes through focus. Another light ray is passing through center of curvature. Okay, so another light ray is passing through center of curvature. So now you can observe when light ray is, so as I mentioned in the earlier, okay, when light is passing along the normal line, so what happened? It reflect back, it retrace path. So it retraces its original path. It moves in the same direction. So in the same direction, okay, how it came, so in the same direction it will move. So here like this, here also I am considering when light is passing, when light ray is passing through the center of curvature, so it retraces, it moves in the same direction or reflect back in the same direction. So the image will form between C and F. If the object is placed beyond center of curvature, if the object is placed beyond center of curvature, the image will form between C and F. So object is placed beyond center of curvature, image will form between C and F. So what about nature? Nature is real and inverted. And what about size? Size is diminished. Why size is diminished? Okay, how can you say size is diminished? So based on what condition you are saying size is diminished? So how it is possible it will be diminished? So with what comparison you are saying size is diminished? With the comparison of height of the object, so image size is decreased. So we have to take the comparison of object size with image. Then by that we can observe, we can conclude that size of the image is decreased compared to size of the object. So that we can say now object is placed between C and F, image is formed, object is placed beyond center of curvature, object is placed beyond center of curvature, image will form between C and F, nature of the image is real and inverted, and size of the image is diminished. Size of the image is diminished. Understood? So object is placed beyond C, image is formed between C and F, nature of the image is real and inverted, size of the image is diminished. So that is second one. Coming to the third one. So here I am considering like this. So this the pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed at C. Image also will form at C. Object is placed at C. Image also will form at C. How many light rays I am taking? One light I am taking like this. So it will pass like this. Another light ray is passing after reflection. So the light rays will meet here. Object is placed at C, image also will form at C. Nature of the image real and inverted. Size of the image is same size. Size of the image is same size. Understood? Coming to the fourth one. Here you can observe. So pole, focus, center of curvature. Object is placed between C and F. So I am placing here. One light ray I am taking like this. It passes through focus. Another light ray is incident at the pole. It reflects back. Those light rays will meet here. Okay. So object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. So compared to object, image size is increased. Understood? Compared to the object, image size is increased. Next one, coming to the fifth one. So pole, focus, center of curvature. Object is placed at F. One light I am taking like this. It passes. So one more light ray incidenting at the pole. Object is placed at F. Image is formed at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Image size is highly enlarged. Coming to the sixth one. So I am taking the concave mirror. Okay, so this is the concave mirror. Object is placed between dun, dun. Pole, focus, center, curvature. Object is placed between F and P. One light I am taking like this. It passes through focus. Another light ray is incident at the pole. It reflects back. So if you are extending these light rays, extended light rays are meeting at one point. Okay. So object is placed between F and P. Image is forming behind the mirror. Nature of the image is virtual and erect, and size of the image is enlarged. Understood? So that's enough. So I hope it is very clear. So this is about concave mirror. So just check once.